In the WaLoWa project, we are researching overtopped wave impacts on storm walls. In Netherlands, Germany and Belgium, the storm walls are often situated on top of a dike, the so-called promenade. And in front of this dike structure, we often have a beach structure where the waves start to break. And during storm conditions, we often find that the waves run up the dike, overtop the dike, and then cause an impact on the storm walls. The aim of this project is to investigate the overtopping flow impacts on storm walls.
Well, this study is quite important because in the Netherlands and in Belgium there are several towns where we have this combination of a sandy beach which is increased in height to stop the waves, but behind it we have this hard structure. And of course we want to know how these structures react to these extreme storms which can occur.
We are here at the Delta Flume where we are carrying out a project in the framework of Hydralab. Hydralab is a consortium of 24 research institutes doing experimental research. We have built here a beach and the waves are traveling over the beach, breaking on that beach, and some wave energy can attack the structure that we have at the end of the beach. There we have a concrete slope and a promenade and then a steel wall. That wall is the main topic of this research because we want to know what kind of forces are on that wall.
There are 5 universities involved in the project. The University of Bari, University of Florence, RWTH Aachen, Ghent University, TU Delft, and the Research Institute Flanders Hydraulics. It is the aim to find research topics for each of the involved partners.
So the people from Italy, they are very interested in the way that the sandy beach changes. The TU Delft, where I am working, we want to know about new measurement techniques and how to get very high resolution knowledge from the facility. The researchers from Germany, they are interested in the wave velocities. And the people from Belgium, of course, they want to know how large are these forces.
The approach of this study is to do hydraulic model tests in a very large scale to minimize scale effects.
The Delta Flume is 300 meters long, 5 meters wide and 9.5 meters deep. And in this facility we can do this kind of research on a large scale.
So we were very grateful that the European Union gave us the opportunity to do this very large-scale testing here in the Delta Flume.
We expect from this study to learn more about the parameters which lead to wave impacts on storm walls and thus enable us to come up with a more reliable design of these storm walls.
It's very important to have those numerical models calibrated on reality. And by calibrating our numerical models, we can also calculate what will happen in a slightly different situation.
So in that way, this research really helps us at a very cost-effective way to prepare our structures for sea level rise.